Hello, my dear students of third prep. Today we are going to start our revision by the general revision. Let us have a variety of examples and problems on your syllabus so as to revise what you have studied all over the whole term. Let us start our revision. Choose the correct answer from brackets. The measure of the arc representing 1/8 of the circle is going to be 45 degrees, 90 degrees, 180 degrees, or 360 degrees. At the very beginning, what is the meaning of the word 1/8? Yes, it is 1/8. 10th, it is 1/10. 9th, it means 1/9. 5th, it is 1/5. So if it is 1th, yani 1/1/. Then, what about the measure of the arc representing 1/8 of the circle? What about the measure of the circle? The measure of the circle is 360 degrees. And I want you to find 1/8 of the circle. So it is 1/8 multiplied by 360 to obtain a result as 45 degrees, which is going to be the first choice, which is 45 degrees. Another example. In the opposite figure, AB and CD are two chords of the circle. AB is parallel to CD. Measure angle B is 40 degrees. Then measure BD arc equals what? Is it 40 degrees, 80 degrees, 20 degrees, or 140 degrees? First of all, when you look carefully at such a figure, you have, that's correct, two parallel lines. And you have the measure of angle ABC is 40 degrees. Then, can you find any other angle from these givens? Of course, yes. As AB is parallel to CD, then measure angle B equal measure angle C equal 40 degrees, as they are alternate angles, the Z letter. So, measure angle C is 40 degrees. Angle C, which kind of angles is it? It is an inscribed angle, which is angle BCD. So what is the relation between the measure of the inscribed angle and the arc subtended to it? The measure of the inscribed angle is half the measure of the arc subtended to it. So we can say that measure angle C equals half measure BD arc. This means that measure BD arc will be twice measure angle C. So it is 2 multiplied by 40 to obtain a result as 80 degrees. Then we are going to choose 80 degrees, which is going to be the second choice. Another example. If the measure of the central angle is 80 degrees, then measure of the inscribed angle that subtends the same arc equals 30 degrees, 40 degrees, 50 degrees, or 60 degrees. At the very beginning, what is the relation between the measure of the central angle and the measure of the inscribed angle when they are subtended by the same arc? That's correct. The inscribed angle is half the measure of the central angle. And as the central angle is 80 degrees, so what about the measure of the inscribed angle? That's correct. It is half of its measure. So half 80 degrees will obtain a result as 40 degrees. Then the choice will be the second one. Another example. The smallest circle that can be drawn passing through the 2 points A and B where AB is equal to 8 centimeters. Its radius length equals what? Is it 1 centimeter, 2 centimeters, 3 centimeters, or 4 centimeters? First of all, you have studied before that the smallest circle that can be drawn passing through two given points is its center will be at the midpoint of the distance between A and B. So as AB equals 8 centimeters, then the center of the circle must be at its middle, at its midpoint. So when the center of the circle is at its midpoint, then we can say that the radius of this circle will be half the length of the 8. So it is going to be 4 centimeters, which is the fourth choice. Another example. If ABCD is a cyclic quadrilateral, measure angle A plus measure angle C minus 80 degrees equals what? Is it 60 degrees, 80 degrees, 100 degrees, or 180 degrees? At the very beginning, what about ABCD? It is a cyclic quadrilateral. You have studied before that the sum of each two opposite angles in a cyclic quadrilateral is 180 degrees. Then what about measure angle A plus measure angle C? That's correct. Their sum is A. It is equal to 180 degrees. So by substituting for measure angle A plus measure angle C by 180 degrees, then 180 degrees minus 80 degrees, you are going to obtain a result as 100 degrees, which is going to be the third choice. Another example. A circle cannot be drawn passing through the vertices of square, rectangle, parallelogram, or isosceles trapezium. It means that which of the following figures cannot be a cyclic quadrilateral? First of all, the square. All its angles are, that's correct, 90 degrees. So the sum of two opposite angles, 90 plus 90 equal 180 degrees. So sum of two opposite angles is 180, then the figure will be cyclic. So the square is going to be a cyclic quadrilateral. What about the rectangle? The rectangle, all its angles are right angles. So each angle will be of measure 90 degrees. The sum of two opposite angles, 90 plus 90, to obtain a result as 180 degrees. Then sum of two opposite angles is 180 degrees. Then the rectangle will be a cyclic quadrilateral. What about the parallelogram? Then two consecutive angles is 180. The sum of two consecutive angles is 180. And each two opposite angles are equal in measure. So as the two opposite angles are equal in measure, then this figure is not be a cyclic quadrilateral. So the figure which we cannot make it as a cyclic quadrilateral, or a circle cannot pass through its four vertices, is going to be the parallelogram, which is going to be the third choice. Another example. In the opposite figure, E belongs to BC ray. Measure angle ABE equals 100 degrees. Measure angle CAD equals 50 degrees. Then measure angle ACD equals what? Is it 50 degrees, 100 degrees, 80 degrees, or 30 degrees? First of all, when you look carefully to such a problem, what about the figure ABCD? Yes, the figure ABCD is a cyclic quadrilateral. So measure angle ABE equals measure angle D equals 100 degrees, as the measure of the exterior angle equal the measure of the interior angle at the opposite vertex in the cyclic quadrilateral. So measure angle ABE will be equal to measure angle D equals 100 degrees. Then in triangle ADC, you are going to notice that measure angle ACD equals 180 degrees minus 100 degrees plus 50 degrees to obtain a result as 30 degrees. Then we can say that measure angle ACD is going to be 30 degrees, which is the fourth choice. Another example, if the measure of the tangent angle is 50 degrees, then measure of the arc subtended by the same arc is how many degrees? Is it 100 degrees, 50 degrees, 40 degrees, or 25 degrees? First of all, what about the measure of the tangent angle? It means the measure of the angle of tangency. So what is the relation between the measure of the angle of tangency and the arc subtended to it? The measure of the angle of tangency is half the measure of the arc subtended to it. And as the measure of angle of tangency is 50 degrees, then the measure of the arc subtended to it is double the measure of the angle of tangency. So we can say that the measure of the arc subtended to it will be 100 degrees, which is going to be the first choice. Another example, a chord of length 8 centimeters is drawn inside a circle with diameter of length 10 centimeters. Then its distance from the center equals how many centimeters? 2, 4, 3, or 6. At the very beginning, as the diameter is 10, then the radius of this circle will be 5. The length of the chord is 8, so its midpoint will be 4 centimeters. So by using Pythagoras theorem, you are going to find that the center is at a distance, how many centimeters? 3 centimeters from the center, which is going to be the third choice. Another example, 2 circles M and N of radii 8 centimeters and 5 centimeters. If MN equals 13 centimeters, then the 2 circles are intersecting circles, distant circles, touching externally, or one circle inside the other. At the very beginning, as the 2 circles are of radii 8 centimeters and 5 centimeters. What about MN? It is 13 centimeters. What is the relation between MN and the 2 radii 8 and 15? MN equals what? Equals the sum of the 2 radii, as 13 equals 5 plus 8. So we can say that MN equals R1 plus R2, and in this case we know that these 2 circles will be touching externally, which is the third choice. Another example, in the opposite figure, measure angle A equals what? Is it 65 degrees, 75 degrees, 50 degrees, or 30 degrees? First of all, can you find any angle from the givens in front of you? Of course, yes. How? Measure angle ACB. What about measure angle ACB? It is 180 degrees minus 115 degrees to obtain a result as 65 degrees, as it is a straight angle. Then, what about AB and AC? AB and AC are 2 tangents to this circle. So we can say that AB equals AC. This means that triangle ABC will be an isosceles triangle. So measure angle B equals measure angle C equals 65 degrees. Then what about measure angle A? It is 180 degrees minus 65 degrees plus 65 degrees to obtain a result as 50 degrees. And this is going to be the third choice. Another example, in the opposite figure, ABC is equilateral triangle, AD parallel to BC. Prove that AD is a tangent to the circle which passes through the vertices of triangle ABC. At the very beginning, as triangle ABC is equilateral triangle, this means that all sides are equal and all angles are equal in measure. So measure angle A equals measure angle B equal measure angle C equals 180 divided 3 to obtain a result as 60 degrees. What about AD parallel to BC? Yes, there are alternate angles. Then we can say that measure angle DAB equals measure angle B equals 60 degrees, alternate angles. Then you are going to notice that measure angle DAB equal measure angle C, angle of tangency. So we can say that AD is a tangent to the circle which passes through the vertices of triangle ABC. Another example, in the opposite figure, measure angle BAC equals 65 degrees, measure angle BEC equal 95 degrees, measure angle DCA equal 30 degrees. Prove that the figure ABCD is a cyclic quadrilateral. First of all, to prove that this figure is a cyclic quadrilateral, you are going to choose one of the three cases which you have studied. Then, as the diagonals are joined, so you are going to try to find a relation between two angles having the same base and on the same side equal in measure. Then, as angle DEB is a straight angle, and as measure angle CEB equal 95 degrees, then measure angle DEC equals 180 minus 95 equals 85 degrees. And in triangle DEC, measure angle CDE equals what? The sum equals 180, so it is 180 minus 30 degrees plus 85 degrees to obtain a result as 65 degrees. Do you notice? That's correct. Measure angle BAC equal measure angle BDC equals 65 degrees. And they are having the same base BC and on the same side of it, so we can say that the figure ABCD is cyclic quadrilateral. Another example, in the opposite figure, circle center M, AB equals CD, measure angle XMY equals 130 degrees. X and Y are the midpoints of AB and CD respectively. Find with proof measure angle MXY. First of all, as M is the center of the circle and X is the midpoint of AB, it means AX equals XB. So we can say that MX is perpendicular on AB. And by the same way, as M is the center of the circle and CY equals YD, as Y is the midpoint of CD, so CY equals YD, then we can say that MY is perpendicular on CD. Then MX is perpendicular on AB and MY is perpendicular on CD. And as AB equals CD, two equal chords, then they are equidistant from the center of the circle. Then MX equals MY. Then in triangle MXY, as MX equals MY, so this triangle is isosceles triangle. Then measure angle MXY equals measure angle myx equals 180 minus 130 divided by 2 to obtain a result as 25 degrees. And in this case, we can say that measure angle MXY is going to be 25 degrees. In the figure opposite, XY and XZ are two tangents to the circle at Y and Z. Measure angle YXZ equals 80 degrees. And measure angle ELZ equals 130 degrees. Prove that first ZE equals ZY, and second XZ is parallel to YE. At the very beginning, when you look carefully at the figure opposite, you are going to notice that XY and XZ are two tangents drawn from a point outside the circle, so they are equal in length. Then we can say in triangle XYZ, XZ equals XY. Then measure angle Z equals measure angle Y equals 180 minus 80 divided by 2 to obtain a result as 50 degrees. Then the measure of each angle of Z and Y is 50 degrees. Then, as the figure ZLEY is cyclic quadrilateral, then measure angle Y equals 180 degrees minus 130 degrees equal 50 degrees. So, as XZ is a tangent and ZY is a chord of the circle, so the angle of tangency is equal to the inscribed angle subtended by the same arc. So we can say that measure XZY equals measure angle ZEY equals 50 degrees. Then in triangle ZYE, you are going to notice that measure angle Y equals measure angle E equal 50 degrees. And as ZE and ZY are equal, then measure angle XZY equals measure angle ZYE equal 50 degrees, as they are alternate angles. And as they are alternate angles, it means that XZ is going to be parallel to YE. In the opposite figure, circle center M, AB equals CD, measure angle MXMY equals 130 degrees. X and Y are the midpoints of AB and CD respectively. I want you to find with proof measure angle MXY. At the very beginning, as M is the center of the circle and X is the midpoint of AB, it means that AX equals XB, then MX will be perpendicular on AB. By the same way, as M is the center of the circle and Y is a midpoint of CD, then CY equals YD, then you are going to notice that MY is perpendicular on CD. Two perpendicular distances, MX and MY. What's the relation between them? As AB equals CD, two equal chords, then they are equidistant from the center of the circle. So MX is equal to MY. That's correct. Then, what about triangle MXY? In triangle MXY, you have MX equals MY. So the triangle is isosceles triangle. Two sides are equal in length. Then their base angles are equal in measure. So measure angle MXY equals measure angle MYX equals 180 degrees minus 130 degrees over 2 to obtain a result as 25 degrees. So measure angle MXY is going to be 25 degrees. Another example, in the figure opposite, M and N are two congruent distance circles. E is the midpoint of NM. Prove that AB equals CD. At the very beginning, as MX is perpendicular on AB and NY is perpendicular on DC, it means that measure angle XEM equal measure angle NEY, and they are vertically opposite angles. And as measure angle ENY equal measure angle EXM, then we can say that in the two triangles NYE and MXE, you have, that's correct, measure angle XEM equal measure angle NEY. Measure angle XME equal measure angle YNE, and ME equals NE. Therefore, the two triangles NYE and MXE are two congruent triangles. In this case, we can say that NY equals MX. So the perpendicular distances are equal in two congruent circles, as NY is perpendicular on DC and MX is perpendicular on AB. So we can say that the two chords A and B are we can say that the two chords AB and CD are equal in length. By the end of this example, we have reached the end of our syllabus, the end of our revision, the end of the year. The holiday is coming. I wish you the best of luck in the exams and in the holiday, and I wish all of you the best of the success. Thank you and bye-bye.
الرحمن الرحيم. أبناء وبناتي طلاب المدارس الثانوية الزراعية، أهلا ومرحبا بكم في لقاء جديد وحلقة جديدة